surface area and dimensional change. The lesson before this, you were asked to find surface area of a net. And now what we're going to do is we're going to find surface area of three-dimensional figures, not using nets, but a formula. And we're going to revisit dimensional change. So surface area in prisms and cylinders with dimensional change will not be taught in isolation. The unit includes calculating lateral and total surface area along with how dimensional change will affect perimeter, area, and volume. Students will need to be able to calculate lateral surface area of a prism and cylinder. You'll also need to be able to calculate total surface area of prisms and cylinders. And you'll need to know how dimensional change will affect the perimeter, area, and volume of a shape. While we are traveling through this, let's go over some vocabulary. Big B represents the calculation of the area of the base. This is different from a little b. P represents the calculation perimeter of a base. So big B is the area of the base. P is the perimeter of the base. Perimeter is the continuous line forming the boundary of a closed geometric figure. In other words, it's the length around a closed figure. Surface area, the total area of all the surfaces of a three-dimensional object. Lateral surface area is the area that includes all the faces but does not include the bases of a three-dimensional object. A prism is a three-dimensional figure named by the shape of the base of the two parallel bases which are congruent. All lateral faces or sides are rectangles in a prism. A cylinder is a three-dimensional figure that has two congruent circular bases. Area of a circle is pi r squared. When calculating the dimensional change of perimeter, since perimeter is units, then the new perimeter is the old perimeter multiplied by the scale factor. When calculating the dimensional change of area, since when I label the area in units squared, then the new area is the old area multiplied by scale factor squared. When calculating the dimensional change of volume, since the volume is labeled with units cubed, then the new volume is the old volume multiplied by the scale factor cubed. Here are some videos for you to peruse. You can take a phone and look at this QR code and it'll bring up they bring up YouTube videos about surface area of a prism, surface area of a cylinder, dimensional change of perimeter and area, and dimensional change of volume. We are going to look at surface area rules. So if you're doing a prism, you have triangular prisms, rectangular prisms, isosceles triangular prisms. You're going to have right triangular prisms, rectangular prisms. I'm not going to deal with these two as much. For cylinders, so you're going to name it by its bases. Two bases are parallel to each other and congruent. Lateral faces are rectangles. So this is a triangle base, and the faces are all rectangles. Your formula can be found in your formula chart. It's S equals PH plus 2B. P represents the perimeter of the base. H represents the distance between the two bases. B represents the area of a base. This needs to be calculated separately. If you're doing a cylinder, remember circles are just snotty figures. And there we're going to do the perimeter of a circle, but that is circumference, so that's 2 pi r instead of the p. And h is still the distance between the two bases. And two areas of the bases, and the area of a circle is pi r squared. P represents the perimeter of the bases in 2 pi r, which is calculating the circumference of the circle. H represents the distance between the two circles. B is always pi r squared because the base is a circle. If you are going to do lateral surface area, it is S equals PH. It's the faces, no bases. And cylinder for lateral surface area is the circumference of a circle times the height. because the circumference of a circle, if I lay this out, that is actually a rectangle. Here are formulas for dimensional change. When you are calculating surface area, you should name the figure, identify the base by the name of the figure, identify which formula to use. If it's a prism, then you're going to calculate the perimeter of the base. If it's a cylinder, then you're going to calculate the circumference of the circle by using 2 pi r. Then you're going to calculate the area of the base. Then you're going to add the perimeter times the height to the area of the two bases. That's how you get up with pH plus 2b. And that is where the introductory notes stop. And I will go into a more specific video with specific problems.